Hi, this is Nat, and this is part 2 of our video lesson on place value. This time through, we're going to be covering these second two things listed. We want to be able to write decimals and whole numbers in standard, expanded, and short word forms, and we also want to be able to compare and order decimals and whole numbers. So we're going to jump right into it. I can write decimals in 3 different ways. The one that you are familiar with, probably, is standard form. It's the one we've been using in the previous lessons as well. So, for example, I can write this, and that's standard form. So standard form ends up being, pretty easy. It's what we're used to. Expanded form is when we take each of the pieces of the number and break them out by their place and value. Let me show you what I mean by that. If we go through this number and examine each digit by its value, this 2 is in the tens place, so it has a value of 20. The 4 is in the ones place, so it has a value of 4. This is from our previous lesson, if you remember. Our 3 is in the tenths place, so it has a value of 3/10. Our 2 is in the hundredths place, so it has a value of 2/100. And our 1 is in the thousandths place, so it has a value of 1,000. To write a number in expanded form, we take all these different values and we just list them in a long string with addition in between. So the expanded form of this number, 24 and 321 thousandths, is 20 plus 4 plus 3/10 plus 2/100 plus 1,000th. And that's expanded form. If there's ever a place in the number that has a 0 in it, so that place has no value, so imagine a scenario where there were, say, 0/10 instead of 3/10, you just skip that entirely. You wouldn't have to say plus 0/10. So expanded form is just taking the number and breaking it apart by its different place values. That gets us to short word form, which is the way we don't actually write typically decimals this way, but it's the way we say them if we're saying them correctly. So we want to get out of the habit of saying 24.321 and actually start saying decimals the correct way, which is done like this. We start by ignoring everything up to everything after the decimal point and just say the whole value as it is. This is really easy when it's less than 1,000 because there's nothing special to add in. But for this one, you just say 24. So the short word form is going to say 24. And when we're speaking, the decimal is represented by the word and. So 24 decimal and. Then we go ahead and say the stuff after the decimal as a normal number as well, 321. Finally, we mark that 321 in terms of how much it is by saying the last place name that it occupies. So if we look at this number up here at the top, we have tenths, hundredths, thousandths. So I'm going to name this 321 thousandths. And I'm probably going to run out of space, but that's the idea. So 24 and 321 thousandths is how I say this in short word form. Let's do another quick example. Here's the standard form of a number, and I'm going to start by breaking this out into its different values for the expanded form. So that 4 is in the thousands place, so it has a value of 4,000. The 5 is in the hundreds place, so it has a value of 500. I'm going to skip the tens place because there's no value there, it's a 0. And I'm going to go straight to 2 ones, and 1/10, and 8/100, and that's my expanded form. My short word form is going to be the same sort of thing we did before. I'm going to start by just taking the number up to the decimal point, saying it like I normally would. 4,502, and remember, and represents the decimal, so I don't say 4,502, I say 4,502, and for my decimal, 18, and this is the part that people get messed up on, you name it by the last place it occupies. So my 8, my last value, is in the hundredths place, so I'll name it 18 hundredths. So the full word form here is going to be 4,502 and 18 hundredths. We can pretty much do this from any direction, so really fast, let's take an example of that happening. Starting with the standard form value over here in pink, I can call that an expanded form 40 plus 2 plus 3/10 plus 8 hundredths. That's my expanded form. I could also, in short word form, the way I speak it, say 42 and 38, again, hundredths this time. Hundredths, which I'm going to run out of room for. Okay, we could start with expanded form if we needed to. So I've got this expanded value. I can shrink it all back together to be standard. So that's a value of 3, 4/10, and it doesn't look like there is a hundredths value, so I'm going to put a 0 in for my hundredths because the last thing I'm going to add is that 7 thousandths. Would have been really easy to mess this up and say 3 and 47 hundredths, but you have to recognize when things are missing in this form. So there's no hundredth, it goes 4/10, 7 thousandths. You have to keep that 0 in there to make that work. In short word form, we're going to call that 3, and for our decimal, 407 thousandths, because it ends in the thousandths place. And we can work from the word form as well. 173 is just 173. I like to start with standard form. And as our decimal point, 2/10 is easy. It's a 2 after the decimal. So 173 and 2/10. In expanded form, that is 100 for the 1, 70 for the 7 in the tens place, 3 ones, and 2/10. So that's a fair amount of examples there. So hopefully that seems like it makes sense. The other thing you're going to be expected to know how to do is how to compare and order decimals. And this ends up being pretty easy to do, provided you pay attention to one rule. And that rule is that when you're comparing and ordering decimals, the only place that matters is the highest place value. Let me show you what I mean by that. Here are two numbers that are pretty close together, but they're different, and so one of them is going to be bigger and one of them is going to be smaller. I picked these because they represent a really common mistake students make when comparing decimals to each other. You see that the 23s are the same. They both have a whole value of 23. That's going to be the first thing that I look at. If one of them had had a whole value of 24, that would be bigger. It doesn't matter what the decimal is if the whole number is bigger or smaller. But if the whole value is the same, like in this case, you have to start looking at the decimals. And in this case, I have 7/10 right here compared to 52 hundredths. The natural tendency for students is to assume that longer decimals are larger numbers, but that's not true. Here's the reason for that. If you saw 1/10 compared to 6/10, you'd have no problem saying, okay, 6/10 is bigger, because 6/10 is more than 1/10. But when we start adding things on, let's just add a whole bunch of 9s here. Now I'm getting this really long decimal after the 1/10. But the important thing to remember is that the 6/10 is still bigger. I can make that decimal as long as I want, and 6/10 will always be bigger than 1/10. Only the highest place value matters. All of this stuff following the 1/10 does not add up to an extra tenth. That's the way numbers work. A number in a higher place value is bigger by itself than all the numbers that came before it. So adding a bunch of hundredths and thousands and 10 thousandths and whatnot onto this 1/10 does not change the fact that it is smaller than 6/10. So 6/10 is still the bigger value. So returning to our two original numbers, it doesn't matter at all that 52 is a longer decimal value. The only thing that matters is what's in the highest decimal place. In this case, it's 7 compared to 5. And that actually ends up being really easy. 7 is bigger than 5. 7/10 is greater than 5/10, so 23 and 7/10 is greater than 23 and 52/100. Some students make this easy on themselves by adding extra zeros, which is always fine, to the end of decimals until they're the same length. Let's do that. You can kind of see again why this works. Now we've got 70/100 compared to 52/100, and if you think about it that way, it makes sense that 7/10 is bigger than 52/100 because it's the same as 70/100, and 70/100 is definitely bigger than 52/100. Let's try ordering these 3 decimals that I just added on here. We're going to use the exact same principle here, and let's go least to greatest. So we need to find the smallest value. I'm always going to start with the highest place value, and I can see in this case they've got tens, 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 and none of those tens help me out. So I'm going to move on to ones, and I've got 1, 1, 1. Well, I've got 2 8s and 1 7. So starting from that point, I know that 47 and 6/10 has to be my smallest value because it has fewer ones than the other two. So that one is my least value. Now the other two have the same number of ones, so now I need to move on to the tenths place. So I see 6/10 compared to 5/10. If I'm going least to greatest, 5/10 is less than 6/10. So 48 and 52/100, because it has 5/10, is less than 48 and 6/10. So this is my list of numbers in order from least to greatest. Here's one final example. I've got 3 and 601 thousandths, 3 and 61 hundredths, 3 and 61 thousandths, and 3 and 661 thousandths. This might be a really good time to just add a couple zeros so that they all have the same number of decimals. I can already tell that from my ones place, the ones place is not going to help me. They're all 3s. So I'm going to be looking exclusively at the decimal places here to decide what's bigger and what's smaller. So if they all had 3 decimals instead of one of them being shorter, that might help out. So I'm going to add a 0, and that kind of makes things easier to see. I see that I have 601, 610, 61, and 661. So in order from least to greatest, 61, all the others have 600 thousandths. 61 has 0 tenths compared to 6/10 in all the other situations. So that's got to be the smallest. 3 and 61 thousandths is the smallest. From there I have 601, 610, and 661. 601 is going to be the smallest of those. That'll be my next smallest number. Now I've got 610 compared to 661. Well, 610 is definitely smaller than 661, so it's going to be 3 and 61 hundredths, or 610 thousandths. Then finally 3 and 661 thousandths. So I put those in order from least to greatest. So again, the thing that I can't stress enough is that when you are doing this, you need to be checking place by place, starting with your highest place value and progressing down until you've ordered all of your decimals. Particularly when you're dealing with decimals, we're not looking at how long a number is, we're looking at what's the value in its highest place. All right, and here are your practice problems for the lesson. Good luck.